Hello, and welcome to the Science to Sleep channel. If you're here looking for something calm, gentle, and quietly fascinating to help you drift off, you're exactly where you need to be. Tonight we're going to take a slow journey through the story of human evolution, not like a lesson or a lecture, but more like a quiet walk through deep time, meant for curious minds that are ready to rest. This is a story designed to soften your thoughts and ease you toward sleep as we explore how our species slowly came into being. From tree-dwelling primates to tool makers, fire tenders, and stargazers, it's a story written in footprints and fossils, in bones and DNA, stretching back millions of years and told softly, just for you. If you enjoy relaxed science like this, made to help you unwind or fall asleep, you're welcome to like the video or subscribe to the Sleepy Science channel. It helps others find their way to this calm corner of science, and it means a lot. And if you feel like it, I'd love to know where in the world you're listening from tonight. Whether it's Tokyo or Toronto, Cairo or Cape Town, you're always welcome here. So get comfortable. Let your body grow heavy, and let's begin. Imagine Earth around 66 million years ago, near the end of the Cretaceous period. Dinosaurs still dominated the land. Giant marine reptiles moved through the oceans, and the skies were filled with the wide, leathery wings of pterosaurs. Mammals were there too, but only barely. Small, warm-blooded, mostly nocturnal, they lived in the margins, scurrying underfoot, hiding, surviving in a world that wasn't built for them yet. Then, in a moment that barely registers on geological timescales, everything changed. A massive asteroid about 10 kilometers wide struck the Yucatan Peninsula. The impact unleashed firestorms, tsunamis, and a long global winter. When the dust finally settled, roughly 75% of all life on Earth was gone. The age of dinosaurs was over. And in the quiet ecological space they left behind, mammals and eventually primates began to rise. After the extinction, the world was cooler, quieter, and more open. Forests began to spread, and with them came new opportunities for the mammals that survived. Among these were the first true primates, small, tree-dwelling animals that would one day give rise to monkeys, apes, and eventually us. These early primates appeared during the Paleocene and early Eocene epochs, around 55 to 60 million years ago. They were shaped for life in the trees, with hands and feet that could grasp branches, forward-facing eyes for judging distance, and a growing reliance on vision instead of smell. These changes might seem simple, but they mattered. They allowed for more precise movement, better coordination, and richer social awareness. Already, evolution was beginning to favor brains over brute strength. Looking at the fossil record from this time, we find animals like Plesiadapis, one of the earliest primate-like mammals, with flexible limbs and large eye sockets. Later come forms like Adapis and Notharctus, members of the Adapiform group, resembling modern lemurs. These weren't a direct human ancestors, but part of the wider primate, radiation, the slow branching of species adapting to life above the ground. Many of these primates were no larger than squirrels, but inside their small skulls, their brains were changing. Regions involved in vision, motor control, and social behavior were expanding. Evolution was quietly laying the neurological groundwork for future tool use, language, and thought. As time passed, some primates stayed nocturnal, like modern tarsiers, while others shifted to daytime activity. Daylight brought new challenges and opportunities, richer food sources, new predators, and more complex social lives. Living in trees required coordination, but living in groups required intelligence. Navigation became social. Who could be trusted? Who remembered where food appeared first? Primate brains grew not just to solve physical problems, but social ones. By around 23 million years ago, primates had diversified dramatically. This was the age of apes, when warm climates and dense forest covered much of Africa, Europe, and Asia. Dozens of ape species lived during this time, many now extinct. These were larger-bodied, tailless primates, more closely related to us. They moved through trees with strong arms and flexible shoulders, and some began to spend more time on the ground. Species like Proconsul, Dryopithecus, Sivapithecus, and Uranopithecus represent different evolutionary experiments. Some may be related to modern apes, others were evolutionary dead ends, but all left clues in bones, teeth, and limb proportions about the slow shift from forest canopy to open ground. Sivapithecus, found in what is now India and Pakistan, had a face strikingly similar to modern orangutans. In Europe, Dryopithecus had limbs suited for swinging between branches. Uranopithecus, discovered in Greece, was once proposed as a possible ancestor of African apes and humans, though that idea remains debated. The fossil record here is fragmentary. Jaws, teeth, partial skeletons, but together they whisper of gradual change. Meanwhile, in East Africa, the environment was shifting. Climate change began opening forests into patchy woodlands and expanding savannas. With fewer trees came longer distances between food sources and greater exposure to predators. In this changing landscape, the first hominins, our direct ancestors, began to appear. They were still primates, but they were experimenting with something unusual. Walking upright. Bipedalism would shape everything that followed. Walking on two legs freed the hands, allowed efficient long-distance travel, and changed how these ancestors interacted with their world. It also came with costs, strain on joints, slower sprinting, difficult childbirth. There is no single reason it evolved. Carrying food or infants, staying cool in the sun, scanning for danger, all likely played a role. The earliest known hominin with clear signs of bipedalism is Sahelanthropus tchedensis, dated to about 7 million years ago. Its skull shows a spinal opening positioned for upright posture. Soon after comes Ororhin tugenensis, and later Ardipithecus ramidus, whose skeleton shows a mix of walking and climbing traits. These early hominins didn't walk like we do, but they were clearly on that path. With upright walking came changes throughout the body. The spine curved, the pelvis reshaped, the foot arched, and the hands were freed for fine manipulation. Bipedalism didn't just change anatomy, it shifted survival toward adaptability, learning, and cooperation. By about 4 million years ago, Australopithecus species appeared. Fully bipedal, yet still partly adapted for climbing, they lived across varied habitats. Australopithecus afarensis, best known from the fossil Lucy, shows this perfectly. She walked upright but still carried traces of a life in the trees. At Laetoli in Tanzania, fossilized footprints left in volcanic ash show early hominins walking together, arches visible, toes pointing forward. Not bones, but behavior, preserved in stone. Australopithecus laid the groundwork, and around 2.8 million years ago, a new genus emerged, Homo. With slightly larger brains, more refined hands, and the first stone tools, early humans began shaping their world. Simple flakes became tools, diets grew richer, brains slowly expanded. By the time Homo erectus appeared around 2 million years ago, humans were taller, more mobile, and spreading far beyond Africa. They carried tools, controlled fire, and lived in cooperative groups. Fire brought warmth, safety, cooked food, and a place to gather. Around the fire, social bonds grew stronger. Even without full language, stories were likely shared in simple ways. Skills were passed on, food was divided, trust was built. Fire stretched the day into the night, and with it, the reach of human thought. This control over energy, both physical and social, reshaped more than daily life. Cooking likely changed our biology itself. Over time, jaws became smaller, guts shorter, teeth less heavy. In return, more energy could be fed to the brain. Fire wasn't just a tool, it became a loop. The more we cooked, the better we nourished ourselves, the more brain power we could support, and the more complex our culture became. And all of this, migration, tools, fire, cooperation, happened long before Homo sapiens appeared. The path to modern humans wasn't a jump, but a slow series of changes, each one building quietly on the last. As Homo erectus spread across continents, evolution kept moving. It branched. Isolated groups adapted to different climates and challenges. In some regions, Homo erectus gave rise to new forms, each experimenting with what it meant to be human. In Europe around 800,000 years ago, Homo heidelbergensis emerged, large-bodied, strong, with a more modern-looking skull. In Africa, similar populations blur the line between late Homo erectus and early Homo sapiens. These transitional forms remind us that evolution isn't a ladder. It's more like a braided river, splitting, rejoining, and sometimes fading away. Homo heidelbergensis matters because it likely gave rise to both Neanderthals and modern humans. They hunted large animals, probably with wooden spears shaped and balanced by hand. At sites like Schöningen in Germany, spears over 2 meters long have been found, carefully made and deadly accurate. They built shelters, controlled fire, and may have used pigments and early symbols. Their brains averaged over 1,200 cubic centimeters, nearly ours. This was no longer just a clever primate. This was a being with planning, cooperation, and perhaps ritual. From Homo heidelbergensis came 2 major branches. In Europe and Western Asia, Neanderthals evolved. In Africa, Homo sapiens took shape. For a long time, they developed side by side. Neanderthals, appearing around 400,000 years ago, were cold, adapted humans, shorter, stockier, powerful. Their bones show strength and endurance. They hunted mammoths, lived in caves, buried their dead, and despite old stereotypes, the evidence shows care, creativity, and connection. They made jewelry, used ochre, built structures, and tended to the injured. They weren't failed humans. They were another version of us. Meanwhile, in Africa, our own lineage was forming. The earliest clear Homo sapiens fossils date to around 300,000 years ago, found at Jebel Irhoud in Morocco. These early humans mixed modern and ancient traits. Flatter faces, large brains, slender limbs, but still heavy brow ridges and elongated skulls. Evolution doesn't rush. Early Homo sapiens were part of a wide spectrum of humanity. Their brains were ready, but their behavior was still unfolding. They hunted together, made tools, gathered plants. Symbolism and abstraction were present but faint, waiting to deepen. For tens of thousands of years, Homo sapiens lived only in Africa, sharing space with other hominins. They adapted to forests, deserts, coasts, and highlands. Genetics suggests we didn't come from one small group, but from many connected populations across Africa. This Pan-African model tells a story of movement, mixing, and shared inheritance. Even at our beginning, humanity was complex. Around 70,000 years ago, modern humans began leaving Africa in large numbers. Why is still debated. Climate shifts, population pressure, new tools, new ideas. Whatever the cause, we spread. First into the Middle East, then Europe, Asia, and beyond. Along the way, we met other humans, and we didn't only compete, we interbred. Today, most non-African people carry Neanderthal DNA. Some populations also carry Denisovan traces from a mysterious cousin known mostly from a few bones. This global spread wasn't just movement, it was a mental shift. Around 50,000 years ago, creativity surged. Beads, pigments, carvings, and cave paintings appear across continents. Horses, hands, mammoths painted onto stone. These weren't decoration. They were memory, identity, meaning. This symbolic bloom didn't appear overnight. The groundwork took hundreds of thousands of years. What changed was expression. Ideas moved beyond speech. They were carved, painted, shared across generations. Culture became cumulative. Knowledge outlived individuals. From this point on, evolution wasn't just genetic, it was cultural. With new minds came new lives. Shelters grew complex, clothing was sewn. Landscapes were shaped with fire. Beliefs deepened. Humans crossed deserts, tundras, mountains, and seas. Around 45,000 years ago, people reached Australia, likely by boat. That journey required imagination, trust, and shared vision. Later, humans crossed into the Americas via an Ice Age land bridge. Within millennia, they spread from Arctic tundra to tropical rainforest. Everywhere, humans adapted culturally as much as biologically. This flexibility became our greatest advantage. Other hominins stayed stable. We changed. And yet, we stayed one species. From Borneo to Peru, what made us human remained shared. Learning, storytelling, imagination. For most of our history, we lived as hunter-gatherers, small groups moving with the land. It was a sustainable life, deeply tied to nature and time. Then, around 12,000 years ago, something shifted, slowly, unevenly. In a few places, people stayed. They returned to the same fertile lands year after year. Seeds were planted on purpose, animals were managed, agriculture was born. And with it, the world began to change. For thousands of years, farming and foraging existed side by side. But wherever farming truly took root, it didn't just add a new way to get food, it rewired the entire human world. The earliest clear centers of agriculture appeared in the Fertile Crescent of the Middle East, a crescent-shaped region stretching across parts of what are now Iraq, Syria, Turkey, and Iran. Here, people began domesticating wheat and barley, along with lentils, peas, and flax. Animals followed. First goats and sheep, then later cattle and pigs. What's remarkable is that this shift didn't happen only once. Similar transformations unfolded independently across the globe. Rice and millet in China, yams and oil palm in West Africa, maize and squash in Mesoamerica, potatoes and quinoa, high in the Andes. Different plants, different animals, different landscapes, but the same underlying pattern. Farming created surplus, and surplus changed everything. With more food than immediately needed, people could stay in one place. Permanent settlements emerged, and with them, a completely new way of life. Homes were built from mud brick and wood. Irrigation canals were dug. Grain was stored in clay jars. Baskets were woven. Cloth was spun. Villages grew larger, denser, and more interconnected. And as population density increased, so did social complexity. Work became specialized. Some people farmed. Others made tools, wove textiles, crafted pottery, or led rituals. Social hierarchies began to take shape. Concepts like land ownership, inheritance, and status became embedded in daily life. The rhythm of existence shifted, from the flexible, responsive pace of foraging to the structured cycles of planting and harvest. Time itself became something measured, tracked, and tied to seasons. Living closer together brought new problems. Waste, sanitation, disease, and competition for resources became unavoidable. Humanity had entered a new evolutionary phase. Not a biological one, but a cultural one. The environment was no longer just something we adapted to. It was something we actively built. As villages turned into towns and towns into cities, societies grew increasingly complex. In Mesopotamia, often called the cradle of civilization, the Sumerians built some of the world's first true cities, places like Uruk, Eridu, and Lagash. These urban centers relied on massive irrigation systems and were governed by priest kings who claimed divine authority. Their job was to manage grain, labor, and trade. Here, one of the most transformative inventions in human history emerged: writing. At first, writing wasn't poetic or philosophical, it was practical. Clay tablets covered in simple symbols tracked debts, harvests, and temple inventories. But over time, writing evolved. It became a tool for law, storytelling, and memory. Knowledge no longer vanished with the death of an elder. It could be preserved, copied, and passed forward. This pattern appeared elsewhere too. Along the Nile, ancient Egypt rose with the predictable rhythm of annual floods, building monumental tombs and temples and developing a culture deeply focused on the afterlife. In the Indus Valley, cities like Mohenjo-Daro and Harappa featured grid-planned streets, advanced drainage systems, and standardized weights, clear signs of central planning. In China, early dynasties formed around ancestor worship and oracle bones, heated until they cracked and revealed divine insight. In the Americas, societies like the Olmec and later the Maya developed calendars, monumental architecture, and writing systems of their own. Despite the distance between them, these civilizations shared a common transformation. Surplus enabled structure. Structure enabled belief. And belief held large societies together. But civilization came with tension. Hierarchies hardened, wealth concentrated, warfare became organized. Patriarchal systems, less rigid in small foraging bands, became more entrenched. Human labor was scaled up massively, often unequally. Slavery, taxation, conquest. These systems didn't emerge because humans suddenly became crueler. They emerged because large, complex societies required control and coordination. And once established, those systems reinforced themselves. Still, beneath the empires and monuments, humans were the same beings who once sat around firelight. We still needed meaning, connection, and stories. From Sumer to Egypt, from the Andes to the Ganges, we told those stories in stone and song, in myth and mathematics, in star charts and burial rituals. While civilizations expanded, biological evolution slowed. Our genes continued to adapt, slowly, to diet, altitude, and disease. But the most dramatic changes were now cultural. Evolution shifted from the pace of mutation to the speed of invention. In just a few thousand years, a blink in evolutionary time, humans developed metallurgy, mathematics, sailing ships, calendars, and long-distance trade networks. We mapped the stars, recorded laws, and began asking deeper questions about existence itself. This wasn't just technological progress, it was a transformation of thought. Large populations could now organize around abstract ideas, gods, nations, philosophies, futures imagined far beyond the next harvest. And remarkably, these intellectual revolutions often unfolded in parallel. In Greece, thinkers like Pythagoras and Aristotle sought explanations through reason and observation. In India, philosophers developed intricate systems of logic, cosmology, and ethics. In China, Confucianism and Taoism offered competing visions of harmony and order. In the Middle East, Babylonian mathematicians calculated lunar cycles and square roots centuries before Euclid. Writing, measurement, and record-keeping became tools not just of control, but of reflection. Slowly, humans began not only to live within nature, but to study it, test it, and question it. This shift would eventually give rise to science. Yet through all of this, we remain deeply human. We loved, mourned, danced, and dreamed. We formed families, made music, and told stories long before cities or equations existed. Evolution gave us the raw materials, large brains, dexterous hands, language. But it was culture, cumulative and adaptive, that shaped who we became. Early humans are not gone. Their legacy lives in our words, our tools, our symbols. The past isn't behind us, it's inside us. In evolutionary terms, even empires and global religions are recent. The Roman Republic, the Han Dynasty, Nubia, Aksum, all appeared within the last few thousand years. If all of human evolution were compressed into a single day, recorded history would begin only seconds before midnight. And yet those final seconds reshaped the planet. The last few centuries brought change faster than evolution can track. Technology reshaped our diets, our sleep, our social lives. We cross oceans in hours, speak across continents instantly, and store more information in machines than in memory. Medicine altered survival. Trade blurred geography. Yet our bodies and minds still carry ancient expectations. We crave sugar and fat. We react to stress as if predators still lurk nearby. This mismatch has fueled both brilliance and instability. We cured diseases once seen as divine punishment, but created new chronic illnesses. We connected the world, but amplified anxiety and confusion. We built machines to think and now question what remains uniquely human. Maybe this is simply the next phase. Evolution hasn't stopped. It's shifted from natural selection to cultural feedback. And now, for the first time, our future depends not only on adaptation, but on choice. So, where does that leave us? An upright primate looking outward at the stars and inward at ourselves. Not finished, not final. Just another chapter. A chapter filled with astonishing achievements and fragile systems. We've mapped the genome, walked on the moon, and still struggle to understand consciousness. We are paradoxical creatures, ancient and innovative, tribal and global, fragile and resilient. And perhaps that resilience is our true inheritance, not dominance, but the ability to adapt, cooperate, and imagine something better. These traits didn't come from kings or philosophers. They came from foragers, fire keepers, tool makers, and caregivers who survived through shared effort. Their story runs through us, in our bones, in our instincts, in our curiosity. We are shaped not only by survival, but by connection and meaning. That, too, is evolution. So, as you rest now, maybe beginning to drift, remember this. Your breath, your heartbeat, your thoughts belong to a lineage billions of years old. You are not separate from the past. You are its continuation. In your cells lives the chemistry of stars. In your senses, the memory of forests and fire. And in your mind, the curiosity that carried us from the trees to the cosmos. May you rest knowing you are part of something vast, unfolding and still alive.